Howdy, here I am, Mr. McMurray, with another average of the naturally occurring isotopes problem. This is off of the additional homework page, and this is number 3 off that page. And this particular problem has a slightly different bend to it. Still, we have this concept where the mass is multiplied times the percent, the decimal of the percent. And then we have another mass that is multiplied by an additional percent. And this whole thing should equal a weighted average. But now, like we did in the past, we're going to pull out all the pertinent information, and we're going to find we have a slightly different unknown. We take a look here, and stray mark, we have, well, boron with the atomic mass of 10.013 AMUs, and it's found at a percentage that is unknown. We have boron that has the mass of 11.009 AMUs, and it's found at a percentage that we don't know, and we do know the average, and that average comes out to be 10.810 AMUs. So in the past, we've found the mass, or, well, we found the average. Whereas in this case, we're looking for the percent of each isotope. And so this presents slightly more of a problem, or something that we need to solve for. And the reason being is we have, well, 2 unknowns. But we could actually turn them into a single unknown if we recognize that the 2 percentages, percent, say, sub 1 plus percent sub 2, both have to equal up to 100, or the decimals would have to equal up to 1. So what we're going to do is we're going to say, well, if this particular percentage was considered x, this other percentage could be considered 1 minus x, since both of these must add up to a total that is either 1, or if put in the decimal form, otherwise it would equal 100. So what I'm going to do is say, well, then I have 10.013, and we're going to multiply that by its percentage, which we'll deem x, plus 11.009 AMUs. Now I'm leaving the AMUs out just so the math looks a little bit more predictable for you. And we're going to multiply that by, well, 1 minus x. And the whole thing should equal 10.810. And all of these masses should be followed by AMU. So now we need to pretty much solve for x. So we have some parentheses, so we need to, well, distribute. So I take 10.013x plus 11.009 minus 11.009x equaling 10.810. And now I have some x terms, which I'll highlight for you. Here's an x term here, and here's an x term here. And these 2 x terms need to be consolidated, and we need to consolidate the non-x terms, which, hey, I'll highlight those for you too. I'm good like that. Non-x term, non-x term. So subtract or add like and unlike terms and solve for that x term. And when you do this out, you will find that your x will end up equaling 0.199799. And we have 5 significant digits, I believe. And so that takes us to here. And so that becomes, well, if we wanted to put it into a percent, we'd move 2 to the right. It would become 19.980%. Now that's one of the percentages. And if we subtract it from 100, we could find the other percent, because we just found out the percent for the particular term we deemed x, which here's the one we deemed was x. And since that was our x term, that's the percentage that goes with that term. On the other hand, we still need to find the other percent. So if we subtract from 100, we will find that you end up with 80.002%. And there's the percentage of each of the isotopes. And hope you enjoyed it. And have a great day.